Hello students, uh, today we are delivering one more lecture on rotational dynamics, and today I will discuss some elements of rotational dynamics like uh, angular displacement, angular velocity, angular acceleration, relation between uh, linear elements and rotational elements. So first of all, we should know that before we go to the moment of inertia and angular momentum and talk. So first of all, point number one, angular displacement. Angular displacement. Angular displacement. Okay, angular displacement, comma, angular velocity and angular acceleration. Angular acceleration. तीनों को हम एक ही under the same heading we will try to explain all the three things under the same heading. Angular displacement, angular velocity and angular acceleration. First of all, these elements like angular displacement, angular velocity and angular acceleration, they are defined not arbitrarily, they are defined about a point. They are defined angular velocity about a point, angular displacement all about a point, angular acceleration about a point. If somebody asks you what is the angular displacement, that's not a valid question. He must ask you what is the angular displacement of any object about a fixed point. So first of all, we need to take a fixed point here. Let me take a fixed point here, O. And here is the object which moves in space. And let this object move, it's a particle P or object, particle P, let it move like this. And it reaches here. What I need to know, what is its angular displacement of this particle P about this O? That is the question. When particle was here, this is the radius vector, position of this particle about this fixed point O. When it reaches this point, this particle reaches this point, okay, let it travel from A to B. And now the new radius vector is, okay, R prime. When a particle moves in this arbitrary fashion and reaches B, the question is, what is its angular displacement about the point O? The angular displacement is the angle traversed or subtended or traversed by this radius vector when the particle goes from here to here. So the angular displacement of this object when it comes from A to B is this angle, delta theta. That is all. So angular displacement is the angle traversed by the radius vector about a fixed point. पार्टिकल यहाँ है और यहाँ आ गया, तो इसका रेडियस वेक्टर जो है, जब पार्टिकल यहाँ पहुंचा तो इसके रेडियस वेक्टर ने इतना एंगल कट किया. सो एंगुलर डिस्प्लेसमेंट is the angle traversed by the radius vector, its SI unit is radians. Pi radians is equal to 180 degrees. A particle moving in this path and reaches here, what is the angle traversed or cut by the radius vector about this point is the angular displacement. तो अगर आप डिस्प्लेसमेंट जाना चाहते हैं तो डिस्प्लेसमेंट ये है, अगर डिस्टेंस है वो ये है, ये डिस्प्लेसमेंट है, एंगुलर डिस्प्लेसमेंट ये है और डिस्प्लेसमेंट ये है और डिस्टेंस एक्चुअल ये है और टाइम डेल्टा टी समझो. डेल्टा टी, it takes time delta t to traverse this distance or traverse this displacement or traverse this angular displacement. Time is the same in all the cases, same and simultaneous time. So B, if we need to define what is angular velocity, omega, that is angular displacement traversed per unit time. That is the angular velocity, and it is unit is radians per second. How much angle is subtended in one second? एक सेकंड में इस रेडियस वेक्टर ने कितना एंगल कट किया? That is average angular velocity. It is average angular velocity, of course. Okay. Now, what is angular acceleration? Angular acceleration is when angular velocity changes. The particle moves, it subtends an angle about a fixed point. There is angular velocity, how much angle is cut in 1 second. If this angular velocity changes, that means we have angular acceleration. तो उस सूरत में यहां पर जो एंगुलर वेलोसिटी है, सपोज इस टाइम पर दैट इज ओमेगा 1 और इस टाइम पर ओमेगा 2 एंगुलर वेलोसिटी, दीज आर इंस्टेंटेनियस एंगुलर वेलोसिटीज. They are not average like delta theta by delta t. They have a different definition. Omega 1 and omega 2. So angular velocity is angular acceleration alpha. Angular acceleration. That is equal to omega 2 minus omega 1. Change in angular velocity when particle goes from here to here. Divided by delta t. And the what you call is this unit is radians per second square. That's all. These are the definitions. Angular displacement भी पता चला क्या है, angular velocity भी, angular acceleration. Angular displacement is the angle subtended by the cut by the radius vector, and how much angle is cut in 1 second by the radius vector is angular velocity, and angular acceleration is if the angular velocity changes, then change in angular velocity from initial position to final position divided by total time interval, that is angular acceleration. And angular acceleration is nothing but change in angular velocity in 1 second. That's why we divide by delta t. Okay, now what is it is angular velocity average. What is instantaneous? How we define instantaneous angular velocity? Instantaneous angular velocity. Instantaneous angular velocity. How to define instantaneous angular velocity? D omega. Again, same symbol. What is angular velocity here? What is angular velocity here? What is angular velocity here? At a particular time, at a particular position. How fast the particle is, how fast the radius vector is cutting the angle per second. How fast at a particular point. So that we need to use the calculus for that. That is d theta by dt. You have to differentiate the angle with respect to time. And again the same radians per second. इसका unit है. That is all. This is all about these three concepts. Instantaneous. It is instantaneous angular velocity. Instantaneous angular velocity. मतलब your angular velocity at a particular position, here, not from here to here. From one time to another time, if you are given a time interval, there it is average angular velocity. At a particular single time or single position, if you want to find angular velocity there, you have to define instantaneous angular velocity. That you have to differentiate this theta. What about instantaneous angular acceleration? That is d omega by dt. Instantaneous angular acceleration. Instantaneous angular acceleration. These are the 4 to 5 definitions which you have to remember in order to do rotational dynamics in a very simple and in a very competitive way. Okay, now first is finished. Second point. Second point. Second point. Second point is kinematics in rotational dynamics. Kinematics in rotational dynamics, or kinematic equations in rotational dynamics. What is that? You know, we have kinematic equations like in translational motion, if initial velocity is given, we need to find velocity after some time, and then we write final velocity is equal to initial velocity plus acceleration into time. If we want to find the displacement covered by the particle in translational motion, we write S is equal to ut plus 1 by 2 at square. There are relation like what is the relation between initial velocity square and final velocity square. Final velocity square minus initial velocity square is equal to 2 times acceleration into distance. That's in one-dimensional motion, or for that matter, when acceleration is constant. I want to write kinematic equation in rotational dynamics for constant angular acceleration. Constant angular acceleration. Constant angular acceleration. There also we have those equations what I just told you. Those equations are only for this, what you call as constant acceleration. Here we will again write down the set of equations for constant angular acceleration. Right? Okay. Now, final angular velocity of an object. Final angular velocity of an object is equal to initial angular velocity plus angular acceleration into time interval delta t. It is the same corresponding equation for final velocity is equal to initial velocity plus acceleration into time. And then we have angular displacement delta theta is equal to omega 0 t plus 1 by 2 alpha t square. But t is time interval. It is not instantaneous time, it's time interval. Okay, here theta t is the time interval. It is the corresponding equation for this displacement. S is equal to ut plus 1 by 2 at square. And then we have omega square minus omega 0 square is equal to alpha delta theta. These are the three equations which can be widely used in rotational dynamics when angular acceleration is constant. If angular acceleration is not constant, then again here we have to use simple calculus. That also not any higher calculus, simple rules of calculus we have to use. These are the three equations. These are called kinematic equations in rotational dynamics. Okay. Now let me go to third point. Point third. Third point. Third point. Suppose a particle is rotating in a circle like this with radius r. It is moving with a velocity v. Tangential velocity is tangential to this path, and it is moving in a circle with angular velocity omega. Omega. That is, if it is when it moves in a circle, complete circle in one rotation, it will traverse an angle of 2 pi in time period t. This is also angular velocity theta by time. Angle subtended when it makes a complete revolution, that is 2 pi. Time taken complete one revolution is t. And also that can be written as 2 pi. 1 by t is frequency f. This is also the equation for omega. Okay. Now let me suppose the particle goes and reaches here. Velocity is v, and now radius vector is this, and angle cut by the radius vector is delta theta, and this path distance, that is delta L. Now what is the relationship between delta L, delta theta and r? Anybody can guess. That is delta L path is equal to r delta theta. Anybody's guess is this. The path covered by this particle from A to B is equal to delta L, that is r delta theta. Arc is equal to r theta. If I divide by delta t both sides, that will give me what is delta L by delta t, that is distance by time, that is speed. Not velocity, it is speed, because it is distance. Speed is equal to r. What is delta theta by delta t? That is omega. So you have a relation between speed and angular velocity in a circular motion, right? Or if r is constant, let me suppose the particle moves in a constant in a circle of constant radius. If I differentiate again this v, differentiate it, it is dv by dt is equal to r is constant and it is d omega by dt. So what should I write by what is dv by dt? Rate of change of speed, not rate of change of velocity. Rate of change of velocity, you know, that's acceleration. But what is rate of change of speed? What is rate of change of speed? What is rate of change of speed? Rate of change of speed, I must tell you, it is acceleration, but tangential acceleration. Acceleration in this direction, at. If speed varies, that gives rise to tangential acceleration. Means acceleration in the direction of velocity. It is acceleration in the direction of velocity. Rate of change of speed is just the tangential acceleration. So tangential acceleration is r, what is d omega by dt? That is alpha. One more relationship. So in circular type motion, these two relationships you must remember. V is equal to r omega, and tangential acceleration, be careful about this, is r alpha. R is radius of the circle, alpha is angular acceleration. Okay, this was the third point. Now let me tell you one more thing, important one, fourth point. Fourth one. See here, if it is a sphere, it is the center and it is rotating with omega, initial angular velocity omega 0, 20 radians per second. Let me suppose it is rotating with angular velocity of 20 radians per second. Means, what does that mean? That means if you draw if it is a sphere and if you draw a radius from here to here, this radius vector rotates, moves in a circle like this, it cuts angle 20 radians in 1 second. This, when this sphere rotates, or it may be a disk, it rotates, it is radius vector, it is radius also rotates, and that cuts 20 radians in 1 second. That we mean, what is this angular acceleration, angular velocity. Now let me suppose the angular velocity changes. That gives rise to angular acceleration. Let me suppose alpha angular acceleration is okay. That's 2 radians per second square. Question I will make an example. What is its angular velocity after 4 seconds? It is rotating with angular velocity this, but now some force has acted on it and that has produced some torque, and that has given rise to alpha angular acceleration, and its rotational speed increases, and I have to find its angular velocity after 4 seconds. That's my question. Now what should I do? Let me apply the formula. Omega is equal to omega 0 plus alpha t, delta t. What is omega? Omega 0 is 20, alpha is what? 2, delta t 4 seconds. That is omega is equal to 20 plus 8, that is 28 radians per second. That is the answer. Let me make one more example. One more example. It is the disk. It rotates with angular velocity omega 0 is equal to 50 radians per second. Now there is angular retardation. I mean alpha is negative. Alpha is minus 4 radians per second square. The question is like something like this. After how much time the disk or the sphere or anything, after how much time the disk will stop rotating. And what angular displacement it covers before stopping. स्टॉप करने से पहले इसके रेडियस वेक्टर ने कितना एंगल कट किया, इस रोटेट करता है तो ये जो रेडियस वेक्टर है कितना एंगल कट करेगा बिफोर इट स्टॉप्स. तो पहले हमें ये देखना है कि कितने टाइम में स्टॉप करेगा, इन हाउ मच टाइम इट इज गोइंग टू स्टॉप. इन हाउ मच टाइम इट इज गोइंग टू स्टॉप, दैट इज आवर क्वेश्चन. तो ठीक है, क्या करेंगे. तो अगर ये स्टॉप करता है फाइनली, रोटेट करते करते फाइनली ये स्टॉप करता है, बिकॉज अल्फा इज नेगेटिव, एंगुलर एक्सेलरेशन नेगेटिव, सो फाइनली इट हैज टू स्टॉप, इट विल रिटार्ड. तो इसका मतलब फाइनल जो एंगुलर वेलोसिटी है वो 0 होना चाहिए. तो जरा लगाइए फॉर्मूला, ओमेगा इज इक्वल टू ओमेगा 0 प्लस अल्फा टी, और डेल्टा टी कर दो. इट इज 0, इट इज 50, इट इज -4 डेल्टा टी. तो डेल्टा टी किसके बराबर, 50/4, दैट इज 25/2, दैट इज 12.5 सेकेंड्स. ये है आंसर. सो हाउ मच एंगल इट ट्रैवर्सेस बिफोर इट स्टॉप्स, इतने टाइम में ये कितना एंगल ट्रैवर्स करेगा. तो दैट इज डेल्टा थीटा इज इक्वल टू ओमेगा 0 टी प्लस 1/2 अल्फा डेल्टा टी स्क्वायर. T square. T is the same as T is the same as 12.5 seconds. Now delta theta, the angle that this radius vector covers up to its stop. What is omega 0? That is 50. What is time? That is 12.5 plus 1/2. What is the alpha? That is -4. What is T square? That is 12.5 whole square. तो ये सॉल्व करने से आपको डेल्टा थीटा मिलेगा. ये इजी टू सॉल्व, कोई बड़ी बात नहीं है. तो वंस दैट गेट सॉल्व्ड यू विल गेट डेल्टा थीटा इन रेडियंस. दैट्स ऑल. सो दीज आर सर्टेन एलिमेंट्स ऑफ रोटेशनल डायनामिक्स व्हिच आई wanted to explain to you so that we can go ahead with the rotational dynamics lectures. And now I think they have now coming lectures will become simpler. Thank you.